Welcome to Baozi Training Leetcode solution. If you want the best mock interview experience in North America, feel free to check us out at baozitraining.org. You can simply Google it. If you want to make a payment, here's the PayPal link. There's the normal package and also the premium package and all the FAQs. And if you need anything, unclear or you need help or anything, feel free to contact us at baozitraining@outlook.com. All right, so today we're going to talk about this problem. It's kind of like a continuation of the previous problems, like word pattern 1 and isomorphic strings. And this one is a little bit harder. It's word pattern 2. So the problem is giving you a pattern and a string and trying to find if the string follows the same pattern. So follow means, there's a bijection mapping. If you're not sure about bijection mapping, feel free to click on the word pattern and isomorphic string to learn what exactly is a bijection. And then in this case, what it means is, let's say if you have AB, and then there's a string like red, blue. So it is actually mapping because A can map to red and B can map to blue. Same thing here. A can map to, I think it's like ASD. And then there's no way you can map like AABB to this giant string. Well, the thought process is very similar to word pattern and my isomorphic string. So when I look at this problem, I'm thinking, okay, so we need to make a one-to-one mapping, and then we need to use a set to check whether it's a bijection, which means two characters in pattern A should not map to the same string. Like two different characters in pattern A should not map to the same string in the string. Now, my confusion for when I look at this problem is how to actually list all the different combinations. And then since this problem also is kind of like only asking you for true or false, can I actually have a mathematical deduction function to use DP, dynamic programming? So of course we have to think about how can we actually list all the combos. So there's actually an easy way, right, to think about this problem. So let's say if you have a pattern ABA, so that means you have to map this string in basically three different mappings, ABA to this red, blue, red. You can think about, given this string red, blue, red, how do you actually divide the string into three parts? How many combos are there? So then the problem might not, everybody can actually, I believe, can write at least a for loop to solve this problem. In this case, it will be a 3 nested for loop because the length of this pattern is 3 ABA. If this pattern length is, let's say, is 4, then you have to like a 4 nested loop. If it's a pattern is n, you need the n listed loops. The way it works is, well, first you will map string, you will chop it like this, right? R is its own part, E, and then this will be a string, right? The last part. And then you will slowly increase this, okay? So ED will be one part, and then the left will be another part. EDB, EDBL, EDBLU, EDBL like this. And then after you map to the end, it will be like this. And then if there's still no mapping, you'll be like, okay, let's increase, instead of a length of the first one is R. So the first character in that pattern will map to RE, and then we'll start again. It will be D, and then will be the last part, and then DB, DBL, so on and so forth. So in general, if the length of the pattern is M and the string length is N, the time complexity of this simply is like O in terms of N to the power of N, N to the power of M. Like I said, if it's M is equal to 3, so it's basically N cubic. And then if it's 4 and N to the power of 4, so on and so forth. But more accurately, it actually should be like, oh, it didn't display it correctly. It should actually be Factorial. So it should actually be N if this is M, this is N. So think about it, given this N string, and how many ways you can chop it off. You have to chop it off into the M part. So it's a combination of N, M. So this actually equals to N factorial divided by M factorial and N minus M factorial. This doesn't really matter, but this is actually the exact time complexity of this problem. However, you can say it's literally simply could be n to the power of m. That also works. Okay, so given that, how do we implement this? So it's very similar to word pattern 1, where we keep a mapping of the string, and then we basically need to check every single combos. So the implementation, but there are two caveats. So I will talk about in the implementation where's the two caveats. So okay, so first of all, you do some sanity check. You have this lookup string just as word pattern 1. You have this duplicate set just in order to make sure that there's no two characters that map to the same, two different characters in pattern that map to the same string. And then you return this recursion function. This will be our main recursion function. Let me just view raw, it's fine. So this will be our main recursion function. We'll take in a lookup, a dupe, and then the easiest way to implement this is DFS, is recursion, which is, we always compare two strings at a time instead of writing these multiple for loops, which is because m, the pattern size is undetermined, so it's kind of hard to write it. So recursion will be our best bet. The way it works is, okay, if the pattern, so this is our end condition. If the pattern there's no length and then the string there's a length, so okay, we find the pattern, we should return basically true, or else if it's not equal to 0, this will return false. We always get the first character of the pattern, and then it will start, right? So if this character is already mapped into this lookup table, which means we already saw this character before, so we need to get, okay, what is the mapped string? And then we need to check, this is just a simple sanity check. If the mapped string length is already larger than the previous one, well, there's no need to continue, it's definitely not going to match. And also this will help you to catch the array index out of index exception. Or we need to do is we just get the substring, we get the length, and then we check, okay, if this string actually maps to, maps the next string, like with the same length. If they're not mapping, well, this one won't match. If it match, great. So what you need to do is you need to move on. So you pass in substring 1, which means you exclude the character 0, and then you exclude the entire mapped string character, and then you continue looking. So this is already contains the char part, the character part. If it does not contain the character, well, that's also great. So what we need to do is we need to first of all create this mapping, right? But before we create the mapping, like I said, so you get the mapped string. We need to map every single length of the string. So the way it works is, so if you look at this, right? So, okay, first you have ABA. Let's say you're trying to map with the string red, blue, red. So you map the A character. You haven't seen this A character before? Great. You're going to map A to the R, and then you will continue the recursion, which is BA to the whole thing. Did you see B? No. So you create a mapping between B and E, and then you continue recursion, DFS. So now your job is to map A to this thing. But then you check, okay, A already maps to this R, so this won't work. So how would you do it again? So what we're gonna do it again is we're trying to map B, because B previously maps to the E, that creates E, A maps to the rest. Now we're going to let B maps to ED, so this length, right? And then we'll continue. Oh, well, it still not work. So then we'll do EDB, B maps to EDB, and then B will map to EDBL, so just like this. And if it still does not match, so we'll, for the A part, so A can also map to RE, and then we'll continue. B maps to D, and then A maps to this. Does not work. B maps to this part. B maps to this part. Until A maps to this part, and then B will still map this. So that's basically where the recursion comes from. You need a for loop so that essentially a character should map any length, like from length 1, 2 to the end of the length, so that you will list all the different combos, just as the code here. This is where the for loop is doing. And then for each of the length, you will create a mapped string, and then you need to check, okay, I'm actually seeing this character. Is there actually a previous character mapped to this string before, right? If it is, when I implement this, there's a bug. I actually directly return false, which is wrong. Because if it is already 1, you should not exit the for loop, because you also have other kind of a string in there, right? So it's like, if, let's say, B maps to this string, is already seen before, you should not skip the whole thing. You should actually, okay, just let's continue. B can still map to this part. So this should be a continue. And now you see the string, you create this mapping, you add this mapped string to the duplicate, and then you continue the recursion. This is where the recursion contains. And then with everything mapped, it will just return true. So remember, if this thing does not map, so that means your recursion came back to this one. You want to continue recursion, continue your recursion, you need to remove the character, because you're carrying over the result from the previous round. So you need to remove this mapping from the hash map. You need to remove the value from the duplicate. So these two steps are actually quite important. So those are the two caveats I think I listed. Continue instead of return false. Yes. Well, let's just double check the time complexity. Like I said, this should be a combo of n to the m, but in the big O notation, you can just say n to the power of m, because you list every single possible combinations. And the space complexity, I would just say, is O to the order of m, because we do use a hash map, and then we also use a set, right? But in one single round at any time, the hash map or the set size should not be exceeding m, because that's only m characters you can map. I mean, the worst case, each character mapped to a different thing, it will be om. So that's our bound. Yeah, let me know if you have any more questions on this. It's not that straightforward to list every combo, but it's after the explanation, hopefully it will be more straightforward. Cool. Leave any comments if you have any questions. Till next time, I'll see you guys next time. Bye.